In this video, we're going to look at the topic of expected value. Expected value is what we expect to happen over the long run. It's over a lot of trials, not just the result of one single event. When we're calculating expected value, every event will have a different result, and each of those results will have a probability that's associated with it. And then we use those results and probabilities to calculate expected value using a formula. And that formula is here. And the way that that formula works for us is we take result number one and multiply it by the probability of that result. Result number two, multiplied by the probability of that result. And we keep doing this all the way till we get to the end, where the last of our results is multiplied by the probability of that result. Then, after doing the multiplying, we add all these together to end up with our expected value. Let's take a look at an example of one. A spinner. So think of a game here where you go up and, there's a pointer and you're going to flick that. It's going to spin around the dial and it's going to land somewhere. And so our different results here are that a player could win $4, lose $1, or lose $2. And each of those outcomes has a probability that goes with it. So what we're going to do is we're going to keep track of all that. We're going to have our results down here, which are win $4, lose $1, or lose $2. And then each of those results is going to have a probability that goes with it. And as we look at the spinner, the win $4 outcome that we have, that is 1/4 of the area of the spinner. So we would expect the spinner to land there 1/4 of the time. So the probability of winning $4 is that it's going to happen 1/4 of the time. Similarly, losing $1 is also going to happen 1/4 of the time. And then as we look over here, it looks like losing $2 is going to happen half of the time. But rather than use 1/2 down here, because eventually, as I go through this, I'm going to want these fractions to have a common denominator. Instead of using 1/2 for that probability, I'm going to go ahead and call it 2/4 right now. And if we imagine this spinner being cut into 4 equal pieces, 2 of those 4 pieces would be that -2. So it is 2/4 would be the probability of that result. Now we have our results and our probabilities, so we're ready to calculate the expected value. Our expected value for a person who plays this game, who spins this spinner, is going to be, let's see, what was that formula again? We're going to go probability times result. So 1/4 is the probability. We're going to multiply that by the +4, or winning $4. So probability times result, 1/4 of the time, the player is going to win $4, and that's what we see right here. Continuing this idea, 1/4 of the time, the player is going to lose $1, and 2/4 of the time, the player is going to lose $2. Now, all we need to do to calculate our expected value for playing this game, spinning this spinner, is simplify what we have over here on the right-hand side of our equation. So we'll simplify it. Now, if we're going to simplify this, we're going to have to multiply this fraction by this whole number. And just as a reminder, when we multiply these, we might want to write these whole numbers as fractions. And then what we're going to do is we are going to multiply the numerators together. 1 times +4 will be +4. Multiply the denominators together. 4 times 1 on the bottom is just 4. We'll do that with the others. 1 times -1 is -1. 4 times 1 on the bottom is 4. And then 2 times -2 will be -4 on top. 4 times 1 on the bottom will be 4. Now we need to add these fractions together, and this is why it's really nice to have these common denominators already in place. Otherwise, we'd have to get a common denominator before adding, but now we can just add these together. When we add fractions, we add the numerators and leave the denominator the same. So we'll go ahead and add those together. And when we add those numerators, we'll have Positive 4 plus negative 1 plus negative 4 will be negative 1 over 4. And this is about winning and losing money. A lot of our expected value problems are going to be in that kind of setup where it's about money. So instead of leaving it as a fraction, we're going to go ahead and divide negative 1 divided by 4 and get this as a decimal answer. And so the expected value for somebody who plays this spinner is that they'll lose 25 cents per spin. Keep in mind, they can't lose 25 cents on one individual spin because those aren't any of the outcomes. On one spin, they're either going to win 4, lose 1, or lose 2. But over the long run, if they play the game a lot of times, they're going to lose 25 cents per spin. Let's look at another example. This time, we'll have decimals in our problem. When you go to a restaurant, you either order breakfast, lunch, or dinner. The prices and probabilities are as follows. And we see that breakfast cost $8, and the probability of us ordering breakfast is 0.45, which means 45% of the time we're going to order breakfast. Lunch costs $11, and that probability is 0.25. Dinner costs $16, and that probability is 0.30. And our question here is, what is the expected value of what you will spend? As soon as we see expected value in the problem, what we're going to do then is we know we're headed towards results and probabilities, and we're going to use the formula for expected value here. So once we see expected value, we know the process to take. One little side note that I want to mention here, as you look at these probabilities, we have 0.45, 0.25, and 0.3. If we add those up, it's 1.00, which as a percent would be 100%. And that should make sense because we have everything that could possibly happen here. I'm either ordering breakfast, lunch, or dinner. That's everything that could possibly happen. If I add that up, the total needs to be 1 or 100% of the things that could possibly happen. Just sort of something to keep in mind. Okay, so here we have our results, which are breakfast, I'm going to spend $8. Lunch, I'm going to spend $11, and dinner, I'm going to spend $16. The probabilities that go with those, well, these are pretty easy to see. They're right here given to us in the problem as 0.45, 0.25, and 0.30. And so now we can go to our formula for expected value. And our expected value here is going to be the same process as before. Probability multiplied by result. So 0.45 multiplied by 8 plus 0.25 multiplied by 11 plus 0.30, which you could use 0.3 if you want to, times 16. We'll go ahead and multiply those together. And let's see, we have 3.6 plus 2.75 plus 4.8. And adding all those together, we come up with an expected value of $11.15. And that's what we would expect to spend if we go to this restaurant. Not in one trip, but over the long term, we're going to spend $11.15 per trip to the restaurant. Let's look at something that's a little bit different. A raffle. Now, a raffle is going to use the same idea of expected value, but it's a little bit different. If you've ever taken part in a raffle, when you buy your raffle ticket, you don't get the money back. Even if you win, they don't give you the money you paid for your ticket back. And we're going to have to take that into account. 100 raffle tickets are sold for $5 each. There's a grand prize of $200 and 3 second prizes of $50. What's the expected value for someone who buys one of these raffle tickets? Here again, when we see the words expected value in the problem, we're going to have results and probabilities that go with them. And here my results are, well, I could win this grand prize. I could win $200. So I could win $200. But be careful. This is where raffles are different. Because I had to pay $5 up front for my raffle ticket, even if I win the grand prize, I don't actually come out $200 ahead. I won $200, but I spent $5, So I actually come out $195 ahead. I have to subtract the cost of the ticket to see where I really ended up here. And that's $195 ahead. Similarly, there are 3 second prizes of $50. I could win a $50 prize. If I do, I'm not $50 ahead though, because I paid $5 for my ticket. I'm only $45 ahead. And then the other thing that could happen that's really easy to forget when doing a raffle is, well, I could win nothing at all. I could actually just lose the $5 that I spent for my ticket. Now let's find the probability of each of those. Let's see, it's not given to me anywhere in the problem, except it does kind of say there is a grand prize of 200. So there's only one of those out of the 100 tickets that are sold. So the probability of winning that grand prize, the probability of coming out $195 ahead is 1 out of 100. Okay, with that idea in mind, there are 3 second prizes. So the probability of winning a second prize would be 3 out of 100. And nowhere in here does it tell me the probability of losing. But there are 100 tickets sold. If one of them is a grand prize winner and 3 of them are second prize winners, then the rest of them, let's see, there's 4 tickets that actually pay out something, so there must be 96 tickets that I'm just a loser when I buy my raffle ticket. And so 96 out of 100 would be that probability. And now we've reached the point where we have our results and our probabilities, so we're ready to calculate expected value. We'll put that into our formula, and we'll have 1 out of 100 multiplied by plus 195, 3 out of 100 multiplied by plus 45, and 96 out of 100, that's pretty likely that I'm going to lose my $5 I spent on the ticket. Just like we did before with fractions, I'm going to go ahead and rewrite these so that I can multiply numerators and multiply denominators. And we'll have 1 times 195 over 100 times 1. 3 times 45, that's 135 over 100 times 1. And that's a positive 135. And then 96 times negative 5, that'll be a negative 480 over 100 times 1. Just like before, I'm in a really good place here. I have a common denominator, so I can add those numerators together. Plus 195 plus 135 minus 480 is negative 150 over 100. And then we're going to go ahead and divide 150 divided by 100 to wind up with negative 1.5, which we're going to write as negative $1.50. The expected value for someone who buys one of these raffle tickets is they expect to lose $1.50 on buying that ticket. Another type of question is very similar to a raffle, and it involves a warranty. A warranty for a new refrigerator costs $80. The cost and probabilities of repairs are as follows. We might get minor repairs costing $50, and the probability is 0.18. We might get major repairs costing $200, and the probability is 0.07. And then it says, the rest of the time, there will be no repairs necessary. What is the expected value of buying this warranty? And so we see expected value in there. So we're going to go to the idea of having results and probabilities. And the results here are a little bit involved because there are minor repairs costing $50. Well, that's true, but it's not going to cost me $50 because I have this warranty in place, although I did pay $80 for that warranty. So even if my $50 repairs are covered because I spent $80 on the warranty up front, if this thing happens, I'm actually down $30. That's that result. And then another result that could happen would be, well, I could have major repairs. Those cost $200, which I don't have to pay for it, which is great, but I did spend $80 on the warranty. So if that happens, I'm actually $120 to the positive because I only spent $80 and it would have cost me $200. And then there's this other thing we don't want to forget about here. The rest of the time, there will be no repairs. Well, if there's no repairs, that means I spent $80 and I didn't get anything for it other than some security, which has value. But as far as the money goes, I'm at negative $80. Those are the three different things that could happen. I could have minor repairs where, okay, there were minor repairs. I didn't have to pay this $50 bill, but I did pay $80 up front, so I'm down $30. There could be major repairs that cost $200. I'm lucky I don't have to pay for those, but I did pay $80 up front, so altogether I'm ahead by $120. And then finally, if there's no repairs necessary at all, I spent the $80. I didn't get anything back for it, so I'm just down $80. Those are the three things that could happen. Now, the probabilities that go with them. I can see the probability of minor repairs, which is me being down $30, is 0.18. And then the probability of major repairs, where I come out ahead $120, is 0.07. I'm not given the probability of no repairs. I don't know what that's going to be. It says the rest of the time. Well, this is where we go back to the idea that everything that happens, if I add all those probabilities together, it has to be 100% of the things, which as a decimal would be 1.00. So if I add up all my probabilities that are in decimal form, I need to get 1.00. So far I have this 0.18 and this 0.07. If I add those, that's 0.25. And so in order to get from 0.25 to 1.00, I'm going to need to subtract and see what the other probability is going to be. That's going to be 0.75. Another way for you to think of this, if it's easier to think it in terms of percents, is 25% of the time I'm going to have a repair of some kind. 75% of the time, which as a decimal is 0.75, I'm not going to have a repair at all. And that's going to be the probability of no repairs. That's going to be the probability that I just spent the $80 and didn't really get any monetary value back. Now let's find our expected value. Our expected value of buying this warranty is probability multiplied by result. 0.18 of the time, you'll lose $30. 0.07 of the time, you'll gain $120. And then finally, 0.75 of the time, you'll lose $80. Now we just need to simplify this. We'll multiply those together and have negative 5.4 plus 8.4 plus negative 60. And we'll add all those together and find out the expected value of buying this warranty is to lose $57. Now, that may be acceptable for the peace of mind that you get for spending the money on the warranty. And so it's okay that your expected value is to lose $57, but it is kind of good to know that going in.